Alright, good morning everybody. This video here is going to try and get you through um, all of the topics that are going to be covered here with your direct variation and inverse variation assignment. The format I'm going to try and do here is do an example problem with each one, and then we can take it to your homework assignment and I will show you one of those problems. Let's start with direct variation. Now the key thing to focus on here for direct variation is its equation. Y equals k times x. Now with one kind of problem that you're going to get, like these ones here, is you will be asked to write the direct variation function as well as graph it. Your first step whenever you see these here, when you start seeing these problems on your assignment, is note what kind of variation you're dealing with here, and that can be told, and you can figure that out in just the first couple words on every single problem. Take a look at the first couple words in this problem. Notice the key word there, directly. So if y varies directly as x, we know what equation we should be using. Now that we have our equation in place for y and x, notice that they give us both y and x in the problem. They give us y here, 6.5, and they give us x right here of 13. So what we're going to do here is substitute those values into our direct variation equation. We put 6.5 in there for y and put 13 in there for x. Your first job here is to solve for k. This becomes an algebra problem where all we have to do to solve for k is just divide both sides by 13. And so now we arrive at our k value here, 6.5 divided by 13. Last time I checked, that is 1/2. So now we can write our direct variation equation. The key to writing a direct variation equation, all you really have to do here is take that k value and substitute it right in there and keep y and x as letters. So it's going to look just like this. Y equals 1/2 times x. And now how do you go about graphing these ones here? Well, the cool thing about direct variation functions, think of it as graphing a line in slope-intercept form, in which in our equation here y equals 1/2 x, the y-intercept, the b, is just simply 0. So we know that our graph is going to start right here at 0, 0. Notice that the 1/2 is in the same spot as the slope position here. So to graph the other points, we just have to travel with our rise over run of up 1 and to the right 2. Up 1 to the right 2. Up 1 to the right 2. Broken record, broken record. We can reverse it. And now that we have these points in here, now we can create our line. Okay? So your homework goes exactly the same way. Let's take a look at one of the homework problems. Alrighty, so question number 1 deals with direct variation. How do we know that? It says so right in the first couple words of the problem. So once again, once you've pinpointed that you're actually dealing with direct variation function, let's write the function. Let's substitute the known values in there. Let's solve for k. In this case, now we have to divide both sides by 3. So now we have k being equal to 2. So now let's write the function. The function is going to look just like this. Now we graph it. All direct variation functions have the y-intercept at 0, 0. And then notice the slope here, but then also notice that the scale here, it's graphs counting by 2's. So up 2 and over 1, up 2 and over 1. Notice we can just really count the squares going up 2 and to the right 1. It's no different than going up 4 and to the right 2. Still has a slope of 2. So when it comes to slope, a nice little tip from the pro is that you can really just count the squares. That is, if the squares are both counting by the same amount here, counting by 2 and counting by 2. And so here's our line. See? That's all there is to it. Now let's look at the other kind of graphing problem that you're going to run across here, which is inverse variation. So now I'm back on your note sheet here, and I'd like you to notice that we're on the side that has inverse variation all in large and in charge. They're right in the middle of your note sheet. And notice the subtle difference between these two variation functions now that we're looking at inverse variation. Notice that inverse variation, we're taking k and we're dividing it by x. Back on direct variation, we were taking k and multiplying it by x. That's the subtle difference between the two. So now when we set up our problems, let's set them up now with k being divided by x instead of multiplied by x. Let's take a look at the example. So this is the example right on the right side of that sheet where the inverse variation was spelled out there. So if y varies inversely as x, notice right there, there's inversely, and y is 4 and x is 10, right, and graph the inverse variation function. Well, just like earlier our first move was writing down the direct variation equation, our first move here is write down the inverse variation equation. And now our next step is note the numbers that we're substituting in here for y and x, just like we did before. Let's plug in that 4 and let's plug in that 10. Alright, so now the difference here with inverse variation is to solve for k, now we need to multiply both sides by whatever values in the denominator. So now we need to multiply both sides by 10. So now when we multiply by 10, those are gone, multiply that by 10. So now we have our k value being equal to 40. Now we can rewrite write our equation. Y equals 40 over x. So now we're going to try and graph this one. Let's take a look at another spot of our note sheet and just get a feel for what these graphs are going to look like. Note the shape here on these inverse variation functions. In the math biz we call those a hyperbola. Now a nice little trick you get here with this is if you take a good look over here, you can see that this was the function that they used here, y equals 24 divided by x. Take a look at these pairs of numbers here. What do you notice with all these pairs of numbers? Do you notice that when you multiply those numbers together you get 24? It's pretty easy then to come up with all those pairs of numbers here when it comes to the graph. So if I have y equals 40 here, divided by x, we can generate a table with numbers that multiply together to give you 40. So let's rattle off some pairs of numbers that multiply to give you 40. Well, 10 times 4 would work. So 10 4, good buddy, would be right there. What else can work? 8 and 5 would work, right? So 8 to the right and then 5 up. You have a point right there. What else can we use to multiply to give you 40? Well, 5 8 would work. Us just switching those numbers around. Take advantage of that trick when you see it. And then if we can switch the 5 and the 8 around, we should be able to switch the 4 and the 10 around, which would give us a point right there. Now what you see here is 1/2 of that hyperbola. How do we get that second half, that bottom half right down there? Well, think about it. Once again, when you look at these box numbers here, positive times a positive would give us a positive 24. Isn't it also true that we can take a negative times a negative and still get a positive 24? Let's apply the same concept to our problem up above. Realize here, now I can just take all those numbers that are in my table and make them all negative. So now when we plot those points of -10, -4, it really just switches all these points down here in the third quadrant. -8, -5. -5, -8. And -4, -10. So there's that branch. Okay, homework problem. Alright, on your homework, number 3 looks like an inverse variation problem. Pretty easy to tell. As you can see right here, inverse variation, that's the only thing you're going to have to go off of here. So let's write our inverse variation equation. Let's grab x and y and substitute. Let's solve by multiplication. So now k is -16, which means our equation here is y equals negative 16 over x. So now we got a negative number up there. How is that going to work? Well, if we make our table of values here, now we just need to come up with two numbers that multiply to give you negative 16. So, looking at our table here, it looks like we could fit a couple points in here. Well, ones that can jump out here, we can definitely use positive 1 times a negative 16. So 1, negative 16, about right down there. Note that we could probably use a good 2 and 8, right? So 2 and negative 8. Puts about right thereabouts. You can certainly use 4 and negative 4. And then notice here that we can now just reverse those values. Reverse the negatives, the 1 and the negative 16. Well, we can call it 16 and negative 1. I'm going to do the same for the others, but as you can see here, I think that's good enough for that branch to look at where that branch actually starts to curve. Note this branch isn't going to cross over the x-axis either. And so then when it comes to getting the other ones here, it's not going to be down here in the third quadrant like the last one did. We still need to create these to be negative, so what's going to happen here is now, to get our next couple points, all these negatives are just going to shift over here now, and we can graph them like that. So now we have negative 1, positive 16, which would put us right up here. Negative 2 and negative positive 8. Negative 4, positive 4. And what, negative 16 and positive 1. There you go. Inverse variation. Done deal. Let's look at the next problem, kind of problem on your assignment. So now with these problems, what you're going to have to be able to do, these problems right here, is they're asking you to determine whether the data set represents direct variation, inverse variation, or neither. In other words, they're asking you which one of these two equations here will generate those table of values with those three values that you see there in the table here. Now you can go through and substitute and check and find k and do a lot of algebra there and find k. We got a fast way of doing it. This k value right here, those good old mathematicians that are great at spelling, that's the constant of variation. Note what happens to each one of these if I take the time to solve for k. When I get k by itself for direct variation, I have to divide both sides by x, meaning that k is equal to the y value divided by the x value. For inverse variation, because x is in the denominator here, I have to get y by itself by k by itself by multiplying both sides by x, which gives us the equation k equals x times y. We're going to use this knowledge to figure out which one is which here. So when you look at this first data set here, notice that in each case they say here y divided by x is 3. When you take 9, divide it by 3, you get 3. When you take 24, you divide it by 8, you get 3. You take 30, divide it by 10, you get 3. So because we're taking y and dividing it by x each time and getting the same value there, that's why this function here is showing direct variation. When we look at this one here, notice that when we take the 8 and divide it, the 3 and divide it, and the 18 and divide it, we aren't going to get the same amount each time. So what we look for instead is what happens when we multiply those together. We multiply, we multiply, we multiply. In every single case here we get 36. So since x times y gives us the same value each time, that means that this is inverse variation. You can see why students goof this up. It's because they get the equations mixed up and backwards. They always want to associate inverse with division and associate direct with multiplication. But when you're looking at these problems here, it's actually the reverse case is true. So when we look at these problems here, and we're trying to figure out whether it's direct variation, inverse variation, or neither, I'll give you a little bit of a tip here. I personally find doing an inverse variation check very easy to do. Checking inverse variation is simple just because all you're doing with the x and the y is you're multiplying them together. In a lot of cases, you can ballpark it and know that either the numbers have a chance of being the same or there's no chance of being the same. For example, we look at these right here. If I'm doing a check to see if it's inverse variation, remember inverse variation, we want to see if k is equal to x times y here for inverse variation. 9 times 5, that's 45, right? And 15 times 3, that's also 45. And if we take a second and double check the 12 times 3.75, we also get another 45. So since every single one of these, when we multiplied x times y to get that same k value, that means that this example here was inverse variation. If we look at the other one here, taking a quick look at this, you can see right away that when you multiply them together, this one's not going to be inverse variation. You're not going to get the same amount each time. So then to check to see if it's direct variation, what we have to do is to find our k value here, we take y and divide it by x. So when we take y and divide it by x each time, notice that 0.2 divided by 1, don't let the decimal mess you up, 0.2 divided by anything divided by 1, we just get 0.2. Now what's 8 divided by 40? 8 divided by 40, throw that into a calculator, I'm pretty sure that's 1/5, and I know that 1/5 is 0.2 as well. You take 5.2, divide it by 26. I might need a calculator for that one, just to verify it. And yep, it is 0.2. So in each one of these cases we get the same number each time, and it worked when we were dividing the numbers, so this one here is definitely direct variation. Okay, so homework time. We're down the home stretch here. Let's wrap up this video by looking at these ones here and figuring out if it's direct variation, inverse variation, or neither. Direct variation, remember, it's our k value would be equal to y divided by x. And then for inverse variation, our k value that we're going to find here is going to be equal to x times y. So looking right here, like I said, I like to check this. It's pretty quick and easy. Look at that, 6 times 2, 4 times 3, 1 times 12. Do you notice we're going to get 12 every single time? So since we got 12 every single time, we multiply them together, done. This was inverse variation. We look at this one, multiply, multiply, multiply. You multiply these two, all these numbers together, you're definitely not going to get the same amount. So we can definitely rule out the fact that this is, has a chance of being inverse variation. It has no chance. So now we take the y and we divide it by the x. 30 divided by 24. Let's just reduce that fraction. We can divide both of those by 6. We get 5/4. Notice that this right here itself is 5/4. And then 15 divided by 12, we can reduce that fraction. We can divide them both by, 3. And when you divide them both by 3, you get 5 on top. And then 12 divided by 3 is 4 again. So 5/4, 5/4, 5/4. Through division. So that's direct variation. Notice here, multiply, multiply, multiply. We don't get the same amount. What happens when we divide them? 3 divided by 2. Can't reduce it. 6 divided by 5. Do you notice you can't reduce 6 divided by 5? Now, do you see why we can stop right now? We already checked that to see that multiplying them won't work, so we know it's not inverse. Now, because just the first two didn't match up, now we've established that it's not direct, so we know that the correct answer here, neither. Okay, so tear into that homework assignment and get those problems done and see if we can turn it in by the end of the hour.